This is a quick review of projectile motion. If this is the force diagram for an object, then it's a projectile. And you may recall that's also an object in free fall. You may ask, why are there two different terms for that? I'm not sure, but generally we refer to free fall as something that is moving vertically, whether it's down or up with only gravity acting on it. And a projectile has some horizontal aspect to its motion, so it would have constant horizontal velocity because there are no horizontal forces acting on it. So here's a ball rolling off a table. Let's say it's rolling off with a velocity of 2 meters per second. The force diagram, when it's airborne, would be this. We're assuming there's no air resistance. Now suppose just as the ball leaves the table, we could turn off gravity. And therefore, there is no force at all acting on the object. The object, because of its inertia, would continue at a constant 2 meters per second velocity in that direction. Suppose that we have this object and it's not moving horizontally and it's just in free fall. Then that object would increase its displacement as time went by, and we would see this pattern for accelerated motion that we're used to. The object would accelerate downward minus 9.8 meters per second squared. Now really we have neither an object moving horizontally without gravity, nor do we have an object falling straight down without the horizontal motion. The projectile of the ball rolling off the table has both, and the resulting path is a combination of these two motions. Since we understand constant velocity very well and constant acceleration really well, we like to keep these two aspects of the motion separate when we're analyzing them, and that allows us to figure out the things we need to know. So this is where our table comes in. The horizontal motion variables go in this column, and the vertical motion variables go in that column, and here are those variables that I'm talking about. There is displacement, whether it's horizontal displacement or vertical displacement, x and y respectively, initial velocity, final velocity, acceleration. Those each direction, horizontal and vertical, have their own initial, final, and acceleration. And then there's time, which is common to both. For a projectile that is launched horizontally, like this ball off the table, some things will always be the same. One is the vertical acceleration is the same as free fall, will be minus 9.8 meters per second squared. The horizontal acceleration, since it's constant velocity horizontally, acceleration horizontally is 0. The initial velocity downward when the ball rolls off the edge of the table is actually 0 meters per second, just as if you were dropping something from rest. If we know the velocity horizontally, that is the initial velocity of the projectile, and since it's constant velocity, that will be the final velocity, speaking horizontally, that is. And for the problems you'll be doing, typically the final velocity is not 0. I meant to just say we don't know what it is, and usually we don't care what that is. Often we'll be searching for the horizontal displacement, how far it goes, perhaps the vertical displacement, how far it drops, or the time, how long it's in the air. Notice that the time, there is not a horizontal time and a vertical time. There is just one time, say 3 seconds, that is common to both the horizontal motion and the vertical motion, and that's how long the object is in the air as a projectile. So this is just a basic review of horizontal projectiles, and now I'll do some examples in another video.